Hey everyone, how goes it? Welcome to Computer Science 145. I'm Dr. JJ Shepard, and today we're going to introduce computers and Java. A lot of people think that a computer is something that's absolutely magical, and it's really not. Now, what you can do with a computer is absolutely magical, but it is just basically a tool. The way that we can think about this is a computer is just a system that takes some sort of input, computes, and then creates some sort of output. Now, the purpose of a programmer is to create solutions to problems utilizing this tool that we call a computer. Before we can get to that, we need to understand this tool. There are two major components to all computers: hardware and software. Looking a little closer, when we're talking about hardware, there's two major aspects that we're going to focus on as programmers: the CPU and the memory. The CPU can be considered the brain of the computer. This is the thing that is running the series of instructions that we're issuing to it, and it's what's creating the output. The memory is where we store data and information that can be utilized by the CPU. Now, the main memory that we're going to refer to is called Random Access Memory, or RAM. This is not the only type of memory, because we also have secondary storage, which is a hard drive. Now, understanding memory, all it is a collection of values that can be referenced by these addresses. This is how we are able to store and modify data. Now, going further with data, we have to understand what a bit and a byte is. A bit is a digit with a 0 or a 1 value, and a byte consists of 8 of those bits. Now, with inside of memory, we have this thing that is called the address, which is the numbered location where each byte resides. So we can see over here, this corresponds to the byte address, and this holds the number of bytes here. Inside of memory, the address is the number location where the byte resides. So as this example shows, we have these various addresses that are arbitrarily picked, and also these values that are arbitrarily picked as well. Inside of a computer, all data is encoded as a 0 or 1. Everything is a bit. Everything in a computer is a number. Now, when more than one byte is needed, then several adjacent addresses are used. Going further with these concepts, a file is a large group of bytes that's stored into auxiliary memory, your hard drives. Now, for files, we understand that files have names, and most files have extensions. These usually indicate the type of file. We usually group together collections of files into what's called a folder or a directory. Now, as we're going to be developing Java programs, the thing that we have to keep in mind is the source code has the extension .java. This is what we are writing. Now, what is produced by the compiler is what's called a bytecode or a .class file. We'll explore this in more detail in a little bit. Now, putting together the hardware with how we run software, this is basically the sequence of running a program. All of our software is stored on our secondary memory, our hard drive. Before we can run the software, it has to be loaded into our main memory. Once it's inside of our main memory, the CPU can access that information. It can fetch instructions. So in essence, it can start running the code from the main memory. Now, the CPU also utilizes the main memory in order to store information and also modify information. And we can just basically think that most of our programs are running in this cycle. The CPU runs the instructions, the memory stores the information. Now let's take a look at software, because once again, it's our job as programmers to create solutions to problems. Now we have to understand that an algorithm is simply a set of instructions to solve a problem. An algorithm doesn't necessarily need a computer. However, more specifically, a program is a set of instructions for a computer to follow. This is what we are developing. In order for us to program, we have to utilize programming languages. And they're called languages very specifically because in essence, what we are doing is communicating with the machine in order to solve the problem. Some programming languages can be considered low level, and the two most obvious ones are called machine code and assembly. Machine code and assembly is the only thing that the CPU can understand. But the problem with this is it's very hard for a human to write machine code and assembly. So, what we decided to do was to develop what's called high-level languages. These high-level languages include things like Java, C++, C#, and Python. The purpose of a high-level language is to make it easier for a programmer to develop the software, and it is also meant to utilize ideas that we are very familiar with in other languages, like for instance, nouns and verbs. Being able to recognize what is a noun and what is a verb will allow you to effectively communicate with the machine. Now, most like other languages, high-level languages have a syntax, which is the rules that govern how this is written. So if we think about us as programmers communicating with the machine, the issue is the high-level language is written more naturally for us to understand, but the computer does not understand that. It only understands machine code. This is where we have to introduce another piece of software called a compiler. The purpose of the compiler is to convert our high-level language into something that the computer can understand. In this course, we are developing software using the Java programming language. To best do this, we need to understand how Java is organized. First of all, when we're developing Java software, we have to create what's called a project first. From there, projects have a collection of what's called classes. And for each one of the classes, we write most of our functional code into things called methods. Looking at this more specifically, classes are the source code. They are the .java files. One important element that is true about Java but may not be true with other languages is the file name of the class must match the name of the class in the file. We'll talk about that in detail later on. And the classes themselves hold these things called methods. And once again, methods are where we're going to be writing most of our functional code. Java assumes a lot. And one of the things that it assumes that is not true for other languages is everything is considered to be an object. We'll talk about that more a little later. Now, if we put all of this together, let's break it down into the two major steps: compilation and then running the software. When we are compiling our source code, the .java files, we have to run that through the Java compiler. The Java compiler produces what's called intermediate bytecode, or just bytecode for short. These create files with the .class extension. However, once the code is compiled, Java does not create an executable. So then, how do we run Java code? Java uses what's called a Java virtual machine to run all of its software. Java uses what's called a Java virtual machine. This is the executable that all Java programs use. We load the .class files into the Java virtual machine, and this is how we run the software. Now, to best understand this, we need to understand what Java's main purpose was. Java was creating a language that was highly portable. So, in essence, what they had to do was develop executables for different operating systems and different architectures where you can write one Java source file and it works across all these different types of machines. Now, we've been using a lot of terminology, and there's a couple of other pieces that is going to come up pretty often. So let's explain each one. Whenever we say running or executing is when the computer is following the instructions in a program. A statement is an instruction to the computer, and most of them end with a semicolon. As mentioned before, the syntax is the grammar rules for a programming language. There's a special kind of code called a comment, which is ignored by the compiler, and it's generally used to explain the code that we're developing. It's very important to comment your code. Arguments is information that's found inside of parentheses that provides information for methods or other statements. These come up a good bit. A bug is an error in a program, and debugging is the process of removing those errors. Now, one of the hardest elements in this class is debugging. So let's go over the three major classifications of errors: syntax, runtime, and logic. Syntax errors can be considered a grammatical mistake in the program, and these are very common at first. These prevent the program from being compiled. We cannot convert it into something that the machine will understand unless we can compile it. Some very common syntax errors include missing a semicolon at the end of a statement, using the wrong, misspelled, repeated, or incorrectly capitalized identifier, mismatched curly braces, parentheses, single quotes, double quotes, angle brackets, square brackets, etc., etc., etc. Basically, if you have a symbol that has an open element and a closed element, we have to make sure to include both. Runtime errors are errors that's detected when the program is running, but not during compilation. You can think of it in this way. This is when you're running a program and it crashes. And whenever this happens, the computer detects the error and then terminates the program. Some very common ones are dividing by zero, calling a method from a null object, and also an index going outside the bounds of an array. Those last two we go into a lot more detail later on. Finally, one of the most arguably hardest errors to fix are logic errors. Despite the program compiling and running, it somehow produces wrong results. There are a number of reasons that these can come up. Some common ones are not understanding the order of operations. These are just like in math, so we have to make sure that we stick to that. Round-off errors. Computers are not perfect and we don't have infinite memory, so we do have round-off whenever we are calculating information. Also, incorrectly using types or methods. This is also a very common one. Now, putting all of this together, let's go ahead and write a Hello World program. Now, what we see here is called an Integrated Development Environment, an IDE, and specifically this one's called Eclipse. The type of IDE doesn't really matter because most of them function in a very similar way. So what we're going to do is create a simple Hello World program. Now, when we start developing Java programs, we must remember back that they are first organized in projects. In order to create a project, we just go over to File, New, and create a Java project. We'll call this one CSCE145 Hello Yay, and then just click Finish. Now, if it comes up asking if you were to create a module, don't create modules. We're not going to worry about those right now. Now, over to the side here, we have our project. And expanding it, as you can see, we have this folder called SRC. This is where our source code is going to be located. Now, once we've created the project, now we understand that we need to start organizing our code in what's called a class and then a method. To create a class, we're simply just going to right-click the source folder, go to New, and as you can see right here, we have a class. Selecting this, we have to name our class. I'm just going to call it Hello World. Whenever you're naming classes, you should not have any kind of space in the name of the class. Now, in addition to that, we're also going to include what's called the public static void main. This is the main method, and this is where the program knows to start reading instructions from. In the early part of this class, it's a good idea to go ahead and include the main method. Now, once we hit Finish, it already generates some code for us. Now the first thing I'm going to do is clean this up slightly. I'm going to remove this and then just enter down a little bit. Now I'm going to go back up to the top. As mentioned before, commenting your code is important, and one of the first comments that you should make is your name in the file. So what I'm going to do is create a /* and then press enter, and it basically fills this in for me. If it didn't do that for you, all you need to do is write a /* and then a //. Now right here, I'm going to put my name, written by JJ Shepard. This is very important to do. Make sure that you write your name inside of all of your source files. Points may be deducted if you forget to do this. Now once again, this right here is ignored by the compiler. This is just for us to read. And also, this is what's called a block comment. So from right here to right here, all of this is ignored by the compiler. Now a different kind of comment is called a single line comment. And so basically from right here to here, all of this is ignored by the compiler. Now, as we go down a little bit, as we can see, we have this public class hello world. This is the class that we were referring to. And also notice that the class's name, hello world, matches the file name hello world. It is required in Java that the class name matches the file name. If it does not, there's going to be a syntax error. So this is the class, and we understand that code is organized further into what's called methods. This method right here is called the main method, or the entry point. This is where the computer knows to start reading the instructions. And instructions are read sequentially, one line at a time, left to right, up to down. What I'm going to do is first output something. To do that, I'm going to write system.out.println, print line. Inside the parenthesis, it needs some kind of argument. In order to print something out, I'm going to create a string. And a string is denoted by double quotes. And all I'm going to put inside of those double quotes is hello world. Now, if you notice, we currently have an error on this line. And that's because we forgot to put a semicolon at the end of this statement. Now, once we've done that, we can see that we do not have any kind of syntax errors, and so we can start running the software. We first have to compile it, then run it. This is all grouped together in this little play button up here. This generates the hello world.class file that is then loaded into our Java virtual machine and then is run on our computer. So once I hit play, it just prints out hello world to our console. You can think of the console as basically being the command line. Now let's do something more than just saying hello world. Let's output something else. System.out.println. I can add numbers and such. So give me numbers. So when we run the software again, it first prints out hello world, and then it goes down to the next command, which prints out this. As we can see, this runs sequentially, left to right, up to down. So far, all we've been doing is outputting. How do we get information from the user? In order to do this, we need to use some extra software. Going right outside the class, what I'm going to do right here is call import java.util.scanner. Java util is what's called a package. and package includes other software that was developed by someone else. More specifically, we're going to use this thing called a scanner. A scanner is how we're going to get input from the user. In order to use a scanner, we have to first declare an instance of one and then construct it. We do this by calling scanner keyboard. And then we assign this to new scanner, and inside of its arguments, we say system.in. System.out is the standard system output. System.in is the standard system input. What we have basically done is create this object that we call keyboard and tie it together with our standard system input to read from the console. Now, we need to store two values in memory. So first we have to declare int value 1. Int is short for integer, so that just means a whole number value. And now we assign this to keyboard, so our scanner, and then what we do is call a method from keyboard, and the one that we're going to be calling is called .nextInt. What this does is it reads the next integer value and then stores this into this variable right here. Now let's go ahead and get a second value, int value 2, and we do the same thing, keyboard.nextInt. Now we said we can add numbers and such, so let's add the numbers. Creating a little more storage, we're going to create an int result is equal to value 1 plus value 2. After we do that, well, let's print out the results. So we use system.out.println, and we create the string, the results of, and let's go ahead and append value 1 and value 2, and then also append the result. The results of value 1 plus, add a plus there, plus value 2, add a plus, is plus results. Now, as we can see here, we have a syntax error on this variable. And the reason is, this doesn't match that. We have to be precise and exact when we're using this. So that is correct now. Let's see how this runs. So once again, we first print out these first two statements, 1, 2. We then create this new keyboard scanner, and now we're waiting for this value 1. Let's go ahead and enter the value of 2, followed by the value of 3. And now what happens is, we print out the string, the results of, and then we append what was stored inside of value 1, 2, then append this plus sign plus the value 2, 3, and then we append the result at the end here, and we get this output. In this introductory lecture, we've gone over a lot of different concepts that's going to be further explained in following lectures. But until then, I'll see you next time.